FastMCP 3 implements a callable-based authorization system that evaluates access through Boolean returning functions operating on an AuthContext data class, enabling fine-grained control over component visibility and execution permissions. This mechanism leverages OAuth token validation and scope inspection to determine whether a request should be granted or denied, with all checks combined using AND logic for cumulative enforcement. We are about to examine a custom authorization check that demonstrates how to extend FastMCP's built-in security model by implementing a function that verifies both token presence and specific scope membership. The implementation will reveal how the AuthContext provides access to the current token and component metadata, forming the foundation for flexible access control logic.
From FastMCP server auth import AuthContext. Def my custom checkdex, AuthContext bool. Hash CTX token is access token none. Hash CTX component is the tool, resource, or prompt being accessed. Return CTX token is not none and special in CTX token scopes.
This code demonstrates FastMCP's custom authorization check pattern using AuthContext. The pattern implements a simple callable that receives authentication context and returns a Boolean to determine access. Here, my custom check verifies two conditions: that a valid token exists, CTX token is not none, and that the token contains the special scope in its scopes list. This follows the framework's convention where any callable accepting AuthContext can serve as an auth check, enabling flexible authorization logic based on token claims. The approach provides fine-grained control over access decisions while maintaining simplicity. By leveraging the AuthContext object, developers can access both the current authentication token and the component being accessed, allowing authorization decisions based on component metadata like tags or custom properties. This pattern is particularly useful when built-in checks like require auth or require scopes don't cover specific requirements, though it requires developers to handle the authorization logic themselves, which could introduce security risks if not implemented carefully. Let's break it down.
From FastMCP server auth import AuthContext.
Imports the AuthContext class from the FastMCP server auth module, which provides authentication context for authorization checks in FastMCP.
Def my custom checkdex, AuthContext bool.
Defines a function named myCustomCheck that accepts an AuthContext parameter named CTX and returns a Boolean value. This function's signature matches the FastMCP auth check pattern, where the function will evaluate authorization logic based on the provided context and return true or false accordingly.
Return CTX token is not none and special in CTX token scopes.
Returns true if the AuthContext has a non-null token and that token's scopes include the string special, otherwise returns false. This is a simple authorization check that verifies both the presence of a token and a specific scope requirement. FastMCP3's authorization system hinges on callable-based checks that operate on an AuthContext data class, enabling fine-grained access control through Boolean returning functions. The myCustomCheck function exemplifies this pattern by leveraging the AuthContext to verify both token presence and scope membership, demonstrating how developers can extend the built-in security model. The AuthContext serves as the bridge between the authentication token and the component being accessed, allowing authorization decisions to factor in both token claims and component metadata. This design choice balances flexibility with simplicity, though it places the onus on developers to implement secure logic. The AND logic enforcement ensures cumulative security, where all checks must pass for access to be granted. Ultimately, this approach provides a scalable way to enforce access control while maintaining the framework's modularity.
The scopes whisper special to the token, but the token only hears its own